Hello and welcome to Higher Maths Integration, lesson number 8, definite intervals involving trigonometric functions. In other words, integrating sines and cosines with limits. So question number 1, find the value of the integral from 0 to 1 of the cosine of 2x minus 5 dx. So if we integrate cosine of 2x minus 5 dx, we get 1/2 sine of 2x minus 5. So why do we get that? We are just using what we were shown earlier on, which is somewhere, I'll be up here. There we go. So we're given these. Okay, so I'm just using this one here. So guys, if we need to scroll back to page 11 or 12, page 12 in our notes, please do so to check the formulae. Okay, so 1/2 sine of 2x minus 5 between 0 and 1, so square bracket 0 and 1. So substitute in 1, substitute in the 0, and all of this we could just evaluate on the calculator in one go. Now, in the previous questions, when it was just substituting 0 into x's, we may have noticed that we'd always get a 0. That is not the case here, because we're going to get 2 zeros minus 5. So we're going to be evaluating the sine of minus 5 here, not the sine of 0. So basically, you can't just ignore that one like you may have been doing in the previous questions when evaluating x squareds or x cubes when x is 0. Okay, so just type all of that into your calculator. And a reminder, we must be working in radians 100% of the time when integrating or differentiating trigonometric functions. So make sure you're in radian mode. Question number 2. 3 cosine of x minus pi by 6 dx between pi by 6 and pi by 3. So again, we integrate using the trigonometric rules of integration, which are on page 12. So we get 3 sine of x minus pi by 6 between pi by 6 and pi by 3. So substitute in our upper and lower limits. So pi by 3, so a third is 2/6. So a third minus 1/6 is 2/6 minus 1/6 of pi, which will just be 1/6 of pi, or pi by 6. So this one would be non-calculator because it's an exact value question. Okay, so you would be expected, or you may be asked to do such a thing in any sort of assessment you ever do. So the sine of pi by 6, or thinking in degrees, that is the same as the sine of 30 degrees, which most of us probably know is 1/2 at this point in the course. If not, we'd need to draw our exact value triangles. The sine of 0, I would draw a very quick sketch of the sine curve, and I would find that the sine of 0 is 0 because the height of the curve when x equals 0 is 0. So I've basically got 3 multiplied by 1/2 minus 0, which is 3/2. And I will do a separate video for question 3.